There's a triangle. We are going to rotate this triangle 120 degrees around the point 2, -1. Figure out the coordinates of its vertices after the rotation. To do this, we can create a simple formula. Let's say point K has coordinates a, b, and point P has coordinates x, y. When point P is rotated around point K by alpha degrees, its new position is P' that has coordinates x', y'. This is a right triangle. The length of this hypotenuse is r. This one is x minus a, and this one is y minus b. This angle is theta. From trigonometry, sine theta equals y minus b over r. So r sine theta equals y minus b. Similarly, cosine theta equals x minus a over r. So r cosine theta equals x minus a. Now, let's focus on this right triangle. This hypotenuse is still r. This one is x prime minus a, and this one is y prime minus b. The angle here is alpha, so this angle is theta plus alpha. From trigonometry, sine theta plus alpha equals y prime minus b over r. So r sine theta plus alpha equals y prime minus b. Similarly, cosine theta plus alpha equals x prime minus a over r. So r cosine theta plus alpha equals x prime minus a. What we want to find are the coordinates of P', which are x prime and y prime. Let's rewrite these equations in terms of x prime and y prime. You'll see that sine theta plus alpha and cosine theta plus alpha appear here. To deal with them, we'll use the addition formulas for the sine and cosine. These formulas allow us to break it down into simpler components of theta and alpha. The equations get longer, but they are now expressed using sine and cosine of theta and alpha. Next, we should simplify the equations by removing theta, because it is not given in the original problem. To do this, we use the sine and cosine values of point P. r cosine theta equals x minus a, and r sine theta equals y minus b. By substituting these into the equations, we can simplify everything. This gives us the coordinates of P' after rotating P around K by alpha. We can even express this result using a matrix. If point K is at the origin, that is, A equals 0 and B equals 0, the formula simplifies further. This is the result when point P is rotated around the origin by alpha. Now, let's apply this formula to our problem. Point K is at 2, -1. So A equals 2 and B equals -1. The rotation angle alpha is 120 degrees. Substitute the coordinates of the points you want to rotate. Point 2, 7 changes to this point. Point 3, 3 changes to this point. Point 8, 4 changes to this point. We can express these calculations as a single form using a matrix. With this formula, you can rotate any point on a plane as much as you want. Great job!